Today in class we talked about the graphs of equations. We reviewed some things that should be basic information, starting with how to find a solution, particularly when we're in function notation. So example number 1, if I have f of x equals 10x minus 7, and I want to find f of 2 and f of negative 1. Another way to do this would be to set up a table, plug in those two values, and that's what you're more comfortable with. This function notation means f of x, x being the variable, whatever is replaced here is also replaced here. In the first case that would be 2, in the second case that would be negative 1. So if we want to find f of 2 and f of negative 1, we're going to plug those values in and follow the process through twice. On the first one, 10 times 2 is 20, 20 minus 7 is 13. On the second, 10 times negative 1 is negative 10, and negative 10 minus 7 is negative 17. And we're done. That's all that was required. I'm trying to think if there was something else I wanted to tell you. Oh, there is. Okay, right here, this f of x is the same as saying y. That kind of freaks some people out today. It's the same exact thing as just a y value. In fact, you could write these as a coordinate point if you wanted to, like so. Okay, part B is about intercepts and how to find your x and y intercepts. To find your x intercepts, you're going to plug in 0 for y. To find your y intercepts, you're going to plug in 0 for x. Now, the y-intercept is usually the easier of the two. Let's look at an example and I'll try to show you why. If y equals x cubed minus 4x, let's start with trying to find the y-intercept. So we're going to plug in 0 for x. Y equals 0 to the third minus 4 times 0. 0 to the third is 0, 4 times 0 is 0, and 0 minus 0 is 0. So one of our intercepts is 0, 0. Done. The other one I'm going to plug in 0 where y is and try and solve. When I do that, I need to figure out a way to solve x to the third minus 4x. There is no immediate solution to that where I just move something to one side or to the other. Instead, I'm going to need to factor. So they have an x in common. What remains is x squared minus 4. I know that this is the difference of two perfect squares, so I can reduce that or simplify that a little bit by doing x plus 2 and x minus 2. And then I can set each of these terms equal to 0. So x equals 0, x plus 2 equals 0, and x minus 2 equals 0. Again, I'm doing that because if this part's 0, 0 times whatever these two are is 0. If this one is 0, if I can make this thing equal 0, 0 times these two things is 0. That will cause it to be 0. Here I'm going to subtract 2 from both sides. Here I'm going to add it. Just using those inverses, and that's in general what you're going to do to solve for your x-intercept. And now I have 0, 0, which I already had. I've got 2, 0, which is new, and negative 2, 0. Okay? The last thing we talked about today was symmetry. I think for most people this was probably the new piece. And when we talk about symmetry, we say it's with respect to something. So that kind of just means around it. For example, we talked about symmetry with respect to the x-axis. And we talked about the symbol with respect to. That's a shorthand version of saying that. To check if it has symmetry with respect to the x-axis, we replace y with negative y. And we check to see if we got the same thing, or the original equation. To check if we have symmetry with respect to the y-axis, we replace x with negative x. And again, you're going to check to see if it's the original equation. The last type of symmetry is with respect to the origin, and that is if both of the above happen. Okay? We're going to look at just one example, and then you had some in your homework. If you get stuck on the homework, I'd like to go over those with you kind of one-on-one instead of showing you all of those here. Example 3, x minus y squared equals 1. You'll get the hang of this pretty quick. Now, this right here is a test, so I have to do both of these things, 1 and 2, to be able to see if 3 is going to work. If 1 doesn't work, I don't have 3, but I may still have 2. So I'm going to start by replacing y with negative y. So x minus, and in place of y, I'm putting negative y. If I take negative y and follow the order of operations, I have negative y squared, which is just y squared, because a negative y times a negative y is a positive y squared. And I can copy everything else down around it. Now this is exactly the same as the original, so there is symmetry with respect to the x-axis for this equation, meaning it is symmetrical around the x-axis, like so. If I test for the other piece and plug in if is it symmetrical with respect to the y-axis, I can replace x with negative x. And do that here. When I do that, that parenthesis doesn't change anything, and I can rewrite it as negative x minus y squared equals 1. And as you can see, this is not the same as this. There isn't anything I can do to manipulate it to be the same as this, so it does not have symmetry with respect to the y-axis or the origin. So my answer is it has symmetry with respect to the x-axis. And that's it. Your assignment is A2. Do the best you can and let me know if you have questions.